Okay, we are going to be doing lesson 8.3. We're going to graph the quadratic equation or the trinomial in full with all parts A, B, and C. So let's take a look at that. We are going to be graphing in the form of f of x is equal to ax squared plus bx plus c. We're going to also find the maximum and minimum values of a quadratic function. So this is all the different parts. And again, this is in your student journal. I believe this diagram is on page 257. So we have a couple things to look for here, all right? The graph will open up if A, this value, A, is greater than 0, okay? It opens up like this. And it will open down if A is less than 0. So think about that, less than 0, it's going to be negative. Those were those reflections that we saw, and it would open down. All right, the y-intercept is always going to be C. So C is where it's crossing the y-axis. And the x-coordinate of the vertex can be found using this handy little, you'll find that it's sort of part of the quadratic formula that we'll learn to do later. But right now, if we just take negative b over 2a, x is equal to negative b over 2a. And so here's b, right? Here's a. So you just have to do this little formula. That's going to give you the axis of symmetry, right? When you say x is equal to that value. To find the vertex, we would then plug in the value of x and solve for the output or the y value to get our y coordinate of the vertex. So that's pretty much what we're going to be doing in this chapter. So it's a lot of computation for those of you that like computation. All right, so first we're going to find the axis of symmetry. Remember, we said that that's what x is equal to when we solve this negative b over 2a. And then we want to find the vertex. So here's the function. After you find the axis of symmetry by plugging in the values, let's see, this 2 is A, positive 8 is B, and negative 1 is C, even though we really don't use it right now, other than to calculate. So you can see that you've plugged in, the 8 in the numerator and this 2 times, and then the value of A, which is 2, just calculate it, right? Making sure to pay attention to your negatives and just division, multiplication things. Once you know what x is, once you know this axis of symmetry, you can then substitute it in place, and for every place that there's an x in the quadratic. So negative 2 to the quantity squared, times 2, and then add that to 8 times this negative 2 and minus 1 to get the value or the output or y, so we can get our ordered pair that is the vertex. That's what we're going to be doing. So let's give it a try. So I'll do the first one. We will start with, I like to start with this negative b over 2a. All right, b is negative. So how you deal with the negatives is going to be up to you. You could deal with this negative and this one at the same time and say, that this is going to be b over and then 2 times a, or you can just keep writing it and keeping it in there till the end. So I'm just going to keep it there. So we have this negative 10 over and then 2 times, in this case, a is equal to 1. So the opposite of negative 10 divided by 2, or the opposite of, in this case, it'd be negative 5, so that equals 5. All right, so how you deal with it is your own personal choice. And then we will take this 5. So this is part A, the axis of symmetry. So A, we would say on this one, x is equal to 5. That's our axis of symmetry. Now we need the vertex. And the vertex is going to be the ordered pair. We know that the x-coordinate is going to be 5, therefore we can substitute that in. And I'm just going to change the f of x, which is the output, into a y. So y is going to be equal to, and then 5 squared minus 10 times 5 plus 2. 25 minus 50 plus 2. Okay, now just go left to right. So negative 25 plus 2 looks like y is going to be equal to a negative 23. So part B, we have 5 comma negative 23. So there is the solution for number 1. Okay, number 2, y is equal to a negative 4x squared plus 6x. So this is our A, this is our B, where's our C? So anytime you're missing a piece, we use zeros as placeholders, okay? So might as well just get started using those now. All right, so negative B over 2A is going to be equal to a negative 16 over 2 times negative 4, okay? So I get a positive 2. So for A, x is equal to 2. Okay, so now we're going to use this x is equal to 2 to find y. So I just plug and chug, right? I have a positive 2 that is squared plus 16 times 2, plus 0, doesn't really matter, doesn't change things. So here I'll have 4 times negative 4 would give me a negative 16. 16 times 2, so plus 32 plus 0 equals the y value of my vertex is going to be equal to a positive 16. So I'll put my ordered pair here, 2, 16, and there's my solution. Okay, moving right along is 3. So negative b over 2a. Here's one I'll show you what I'm talking about if I sometimes simplify this. Since I look at this as, this could be a negative b or a negative 2a. If I make this a negative b, I want the opposite of whatever b is. Since b is a negative 8, I can simplify that right away into a positive 8. Now, then I'm only dealing with this negative 2 down here that was a. So 8 divided by negative 4. Now I don't have any other extra symbols floating around. I feel like there's always a lot of symbols up here when I was doing that. So then it's going to be negative 2. So the answer to A, the axis of symmetry is equal to a negative 2. So now I want to solve for y. So negative 2 is my A. I am taking negative 2 and squaring it, right? Negative times a negative is going to be a positive here. Minus this 8 times a negative 2 and plus 5. So I'll have 4 times negative 2. I get negative 8. Then I'll have negative 8 times a negative 2, which is a positive 16, and then plus 5. So we'll have, let's see, 8 and 5, looks like 13. So B, my vertex, is located at the point negative 2, 13. Why don't you go ahead and try number 4? Pause the video, and why don't you find the axis of symmetry and the vertex? Okay, thank you. Okay, just to give you a little bit of closure here, I'm not going to work it out, but hopefully you found that the axis of symmetry, x is equal to 1, and then b, we would locate the vertex at 1, comma 4. So this was the solution to number 4. I'm going to go ahead and erase and move on. Here we go. So now we're going to graph it, and we're going to use the information that we know. So here's what we're going to do. First, we're going to find where the axis of symmetry is, okay? So remember that axis of symmetry is a vertical line at x is equal to 1. Then we will plot the vertex. So we'll do just what we did, and then we have a place to plot the vertex. So the vertex is 1, comma 2. We're going to use the y-intercept. If you recall, the y-intercept in this case is c. So we have 5. Because c is equal to 5, we know that this is a point on the graph. And then, because of the axis of symmetry, we also know that 2, 5 is on the graph. And so now we have 3 points, basically. You know, the y-intercept, the vertex, and the mirror image of the y-intercept across the axis of symmetry to get our parabola or curve. To describe the domain and range, at this point in your learning, domain is going to be all real numbers all the time, because when we graph these, we're going to put arrows at the ends and any input value could be possible. We haven't gotten to the point where we're trying to limit what, setting any limits. So then the range, y is greater than or equal to 2, that's going to be whether or not it, the greater than equal to means that it's opening up. If it were less than or equal to, it's opening down. But it's the output values that would be equal to it, and they'll be pretty obvious once you graph it. So I don't know why they're not showing the graph on this example, but I'm not going to worry about it. All right, because we're going to be graphing them. Okay, so we need to do just what we did, right? We need to start by doing this. Negative b over 2a for number 5 is going to be like a negative 6 over 2 times 3. So negative 6 over 6 equals negative 1. All right, so the axis of symmetry is negative 1. So x is equal to negative 1. If x is equal to negative 1, what does y equal of our vertex? So 3, and then we'll take our negative 1 and we'll square it, plus 6 times the negative 1 plus 2. So 3 times 1 is 3, minus 6 plus 2. So we'll have negative 3 plus 2 is going to be negative 1. So y is equal to negative 1. So we have a vertex of negative 1, negative 1. So when I draw this, I'm going to kind of like, how many did I do? 2? Like go 2 here, get to draw our own, and then anywhere, it doesn't matter, I guess. Okay, get to draw our own x and y. Now, we have an axis of symmetry of negative 1 right here, right? We have this point as our vertex. So this is our axis of symmetry. I'll just keep continuing to draw that down. We know that c is equal to 2, so it's crossing the y-axis at 2. And then, because of our axis of symmetry, we have this mirror image point right here. And now we have 3 points, and we can draw our parabola. So let's describe the domain. So the domain is going to be all real numbers, as evidenced by our 2 arrows. The range, since can't graph perfectly through that, but we have y is equal to, right here at this point, negative 1, and it's going to be above that. So y will be greater than, but also equal to, the negative 1. Notice that you'll be dealing pretty much with the y coordinate of your vertex in describing your range. Okay, I'm going to let you do number 6. Go ahead and graph number 6, pause the video. In this case, we have a couple things. Hopefully you found that your axis of symmetry was equal to, what do I have there? 2. So it was a positive 2. And then I found the vertex to be 2, negative 9. Okay, so your graph looks like it'll be opening up because of this positive 2 value. So you have the domain is equal to all real numbers. And your range is going to be y is greater than or equal to negative 9. All right. And then for number 7, we know because of this negative, or hopefully you can kind of determine or realize that this is going to be opening, down. It's going to open down because of this negative. So we have to first do our, negative b over 2a. In this case, it's going to be the opposite of -1, which is +1, over 2 times this negative, 1/5. Well, won't this be fun? This is equal to 1 over a negative 2/5. So we can't leave a fraction there. We have to multiply by the reciprocal, which is negative 5 over 2. And I could probably just take that to a decimal, negative 2.5. So that's our axis of symmetry right there, negative 2.5. We're going to need to use this value then to find our y coordinate. So we're working in decimals, and this is not fun, but it can be done. So y is equal to, now we're going to have a negative 1/5 times our negative 2.5 quantity squared minus this negative 2.5 and then plus 5. So I'm going to need a calculator for this. So if I take a negative 2.5 and I square it, I get a positive 6.25. I'm going to multiply that by the negative 1/5 times 1/5. All right, so this first part right here, I've got a negative 1.25. Then I'm going to add 2.5. Then I'm going to add 5. So let me go ahead and do that. 2.5 plus 5 equals. So the y coordinate of my vertex is going to be a positive 6.25. Graphing this will not be fun, I can guarantee you. But we're going to have an ordered pair here of the vertex, negative 2.5, comma, 6.25. Let's see, how did I do this? I kind of, over here, we know it's going to open down. We'll do our best. We'll just do our best. I think it's probably going to be best maybe to count by 2s. I don't know. I think I counted by 2s. So if this is -2, right? This is -4. So -2.5 is like probably halfway between here, like a fourth the way over. And then I have 6, so I'll have 2. Well, isn't that just lovely? 4, 6.25. So we'll just put this little, I don't know, vertex right up there. We know that it's crossing at 5. So 2, 4, we know that it's crossing right here, like halfway between 4 and 6. And this is my axis of symmetry. So then that's going to make it like, it's hard to say. Yeah, I do not wish you having to do this without a graphing calculator. Decimals, I hope that I don't give you any with decimals. I will try to remember not to do that because that was just not fun. All right, but let's just describe our domain. Domain, all real numbers, always all real numbers in this case. And our range is going to be y is less than or equal to our 6.25. So that's the describing it right there for you. Okay, apologize for that mess. Thank you, big ideas. All right, so minimum maximum, not a hard concept at all. All right, so it's either going to open up or it's going to open down. We kind of already talked about that. It says here when a is less than 0. So a is a negative number. It will open down. All right, and then we'll have a maximum point. We'll have a high point of our graph. When a is greater than 0, we will have a minimum value, and that's all it means. It really is just kind of describing whether you have it lets you know in math terms whether it's opening up or opening down, maximum, minimum. Okay, that's all it is. So we're gonna find them. So we're gonna determine if it has one. So we're gonna look at this value here, A. Because it's less than 0, we know that this is going to have a maximum value because -4 is less than 0. So the parabola opens down and it has a maximum value. Then we're just gonna find that value, which is basically the y coordinate. um, when so you'll have to use A and B. Here's the math showing you that we get the axis of symmetry as -3. Substitute that in to get the y value or the output value of 17. And so our maximum value is 17. So it's very much the same of what we've been doing this entire time. So here we go. We're going to tell if it has a maximum or a minimum. I'm going to look at this and it's negative. So I know that we're going to have a maximum. All right. And then I'm going to begin to find it. Negative b over 2a is equal to, so the opposite of 5 is +5 over 2 times a -1/2. So that's 5 over, and then this is going to be a -1. So it is a -5. So my axis of symmetry is x is equal to -5. So now I can find my y value and get my vertex and my maximum point, so to speak. So I've got this -5 squared. So 25 times a -1/2 is -12.5 plus 25 plus 2. Um, looks like a positive 14.5. Yep. And that's going to be my maximum value. My maximum value is a 14.5. Okay. Number 9, looking at A. A is greater than 1. That means my parabola opens like up, so I'll have a minimum value. Okay, and to find my axis of symmetry, is -1. So the y value is going to be 8 minus 16 minus 2, or -10, and that's going to be my minimum value. Why don't you go ahead and solve number 10. Tell me if it's a maximum or a minimum, and then give me the value. All right. Hopefully you found that it was a maximum, and it was because of this negative, and the value is -3, the maximum value, which is -3. All right. Now we're going to be working some word problems. So we're going to be doing the same thing, right? But this time it's going to put it in context so you can kind of understand, like, why are you learning how to do this? Well, there are people who have jobs that actually need to know this information. And in this case, it's talking about the suspension cable. So this red part that you're seeing, it's part of a parabola. It's a, what is it? It's a cables between the bridges in Michigan. And here is the function that it models the amount of slack or whatever, or arc at this point in the bridge. And so, X and Y are measured in feet. What is the height of the cable above the water at its lowest point? So we want to know right here, the lowest point. So we need to find all this information. So the lowest point on the cable is at the vertex. So here we have our A value, not fun numbers to work with. Thank goodness we have a scientific calculator. So we can find the X axis of symmetry, then substitute that in. Switch to this. to get that part disappears. All right, and so we substitute that in and we find this value is approximately 203. So the cable is about 203 feet above the water at its lowest point. And that's the kind of stuff we're going to be working with. So let's see what we got. We have a function that's going to represent the height in feet of a rocket t seconds after it's launched. The rocket explodes at its highest point. So looking at A, we know that it's going to have a maximum value, right? Because the rocket is going to go up and then it's going to come back down. And so this maximum will be the highest point, the maximum value, okay? And H is the output is measured in feet and T is a measure of time, right? So we have to kind of understand what those meanings are. So when does the rocket explodes? It explodes at the highest point. So basically in A, if you're looking at the vertex, X, Y, in A, we want to know what is the X coordinate. And at the height that it explodes, since it's going to explode at the vertex, again, Y, the output value, will give us that height. So we just do what we've been doing. We have our negative B over 2A. So we'll have negative 250 over, and then 2 times a negative 16. When I crunch the numbers, I want to get approximately, let me do this, approximately this 7.825. So let's just say that our x axis of symmetry and the time t is at 7.81 seconds, all right, because t is a measure of seconds. All right, so now this is the x coordinate that we're going to use for our height of the rocket. So we're going to have our height is equal to negative 16, and then 7.81, and then we'll have 250 times 7.81. So I'm going to put these in my calculator. So 7.81 quantity squared. And then I'm just going to go ahead and multiply that by this negative 16. And I'm going to, let me write this down. So it's approximate. Let's just do approximates. So negative 975.94 plus, and then we'll have 250 times 7.81. All right. This gives me approximately 976 and 56 hundredths of what are we at? Feet. All right. Since I rounded here to the hundredths place, it just seemed logical to keep it to the hundredths place. All right, that's it. So if you have any questions or concerns, please let me know.